All right, my friends. So in this video, we're going to be talking about abstraction in object-oriented programming. When we say abstraction, we are basically referring to the process of hiding complex implementation details of a class and exposing only the essential features or functionality that the programmer or the developer would want to make use of, right? So this would definitely make it easier, to interact with the objects you're creating. So, and of course, it's going to make it easier because you only need to know how to use them without having to worry about, how they work internally. Okay. So why should we even think of using abstraction? Well, so there are a couple of reasons. I've mentioned a couple of them in this brief explanation I gave here. But let's just take down some notes. Basically, we should be looking at simplification, right? It simplifies, the code base. Next, we can say it makes us focus on what's important, right? Now, this is from the developer's perspective, and we should also understand that it would improve the code maintenance or code maintainability, right? Maintainability. Okay. So these are some things to understand. I mean, imagine you have another developer looking at your code. It makes it easier for them to, debug if there's an issue or if there's a problem with maybe a function or something. Okay. Let's look at a simple abstraction implementation here. So what we're going to be using is the abstract method from the Python core library. So let's just say from ABC imports ABC and abstract method. Okay. Basically, with the abstract method, we're simply going to create, more like the blueprints of our class, and we're going to also create, those methods, and we're going to call them abstract methods here. So this is just a decorator that would apply on those methods. Those methods will not have any core implementation, right? Which is why we're trying to, specify that they are abstract methods. So let's create our class. Let's create a class of shape, and we're simply going to inherit the ABC, which is the core abstract method implementation here. So we're going to inherit that. That's more like the base. All right. So I think the example I want to give is already, coming up here. So let's just pick up that example. You see, I have the abstract method with the method of area. So area here basically just says pass, right? We don't want to have any actual implementation here. We just want to, define the shape of this object, right? So right now we have the class of circle, which inherits from shape. Okay, so shape is basically the parent class here, and you see we have def init with radius. Okay, now we can go ahead to implement the area under, the subclass, which is a circle. We can implement the area with the actual, implementation. Remember that the base or the parent did not have an actual implementation, which is fine. We just want to make sure that these classes tend to follow the defined standards, right, or the defined contract here in the shape class. Okay. uh, okay, let me take this off. All right, so that's what we have now. You see, we also have rectangle, and we can proceed to implement that method for rectangle. So let's go ahead and do that. Now for rectangle, we have the width and height. We can proceed to also include that method. So let's include the method of area right here, and you see this returns self.width times self.height. The point is that we are also, defining that method, but then the functionality, changes from subclass to subclass, right? I mean, it doesn't matter; it can be the same. But the point is that we're able to maintain that, contract, okay? And we have the abstract method defining that, this should be an abstract method in here, and whoever inherits from this should be able to define their own structure or their own implementation of the area method. Okay. All right, so let's just go ahead and create uh, the circle, also create a rectangle with the appropriate params, and we'll proceed to call the area of the circle, right? So how do we do that? Let's go ahead and we just simply have to say circle area. We have to print this, by the way, so let's just print because that will be returned, right? So let's just go ahead and print that to the console. So print, do the same thing here. We don't need to print this guy. Okay. I wanted to show us, what you can achieve with this, but this is basically how we would get that, area. Now we have another implementation. So now we have another implementation here. You see, we have a print area function, which is, outside of both the parent and the subclass. So at this point, it expects a shape. When we bring in that shape, we can simply call dot area, and we rest assured that that would correspond with whichever shape is passed in here, right? Whichever shape is passed in here that inherits from the shape base class, right? They all have the method of area, and this function can be used to simply achieve the same result as what we are trying to do here. Okay. All right. So now we can simply call circle.area, rectangle.area. Likewise, use the function print area that we've defined right here. Okay. So thanks for watching. I'll see you next time. Bye.